All right, so in this one, we're going to be setting up a Windows window. Um, I'm going to focus on just Windows, and I'll deal with other platforms later. So here we are on the Windows documentation for getting a window program running, and it has some sample code here. So what we're going to do is we're just going to copy and paste this sample code straight into our program to get it working. So I want to split this off to be Windows only, as we're going to be doing multiple platforms. So here's where I'm going to create my first source folder. I'll call it window or windowing. Windowing? Yeah, because I don't want to collide with Windows. Windows.go. I'm also going to have a window, so it'd be weird to have a window. Anyways, we'll have package windowing, and we're gonna that code is C code, so we're gonna have a import C here, and I'm gonna paste that code. But first, I'm gonna name it something like window main or something. Void main, and paste that code. I'm gonna format this so that it's a little more in line with what I expect with Go. Not perfect, but I also don't put new lines in my code. I feel like if there's a new line, that's probably because it needs to be in a separate function because you're separating ideas. Anyways, and now we can call our func. We'll just say create window, and this will call C main window. Thank you. And we're going to have a window.go, which this is going to be the publicly accessible window, windowing. And this publicly acceptable, we're just going to make a simple func new. And this is going to call create window. We'll clean this up later to do more useful things. There we go. Error loading, workspace folders. I don't know what this is. Cool, whatever. So now instead of our main, we're going to do window ing.new. And we're going to import Kaiju's windowing. Okay. See if we get a window. Nope, we got a bunch of errors. WD class. Oh, we're going to include our C libraries that we're going to be using. Duh. I'm going to include windows.h. I don't know if I need other ones right now. We'll start with that. Oh, yes, that code we copied, now that I'm thinking about it. It's probably a win main, which has these arguments built into it. So we are going to have to get that instance elsewhere. Let me see where I get that. Okay, I looked up online and there's this fancy function here, get module handle, which will do that work for us. So now we'll try to build again. And now we're at window proc, undeclared window proc. That's because we don't have a window function. I have, where I found that page, I think they have a Windows proc. Yeah, I'm just going to copy that one and paste it in here. Window proc and window proc. Cool. The good thing is, since you're not following along and coding with me, I can just blow through this because the source code is all about the engine. So that's kind of nice. It's not exactly like a tutorial, follow along tutorial, more than it is a this is how the engine was made kind of thing. And now we need to change this guy. You can always pause though if you really want to know exactly what it is that was being typed, and you can copy it down, or you can just go to the engine and check out the pull request that's associated to this, which will be in the video descriptions as well. And we need to change this to SW show. Okay, let's see if that gives us a window. Yay, a window. It says L. That's because it's probably this L. Let me see if I change it to Bairn. Bairn. Yeah, it's a B. Okay. So this is supposed to be a wide char. Let's take a look at what we got here. Yep, there it is. We need to define the Unicode stuff. So let's just put that at the top here before we call Windows. That's likely the problem. Yep, there we go. Cool. We got our window. So now that our window is up and running, I don't know what all is going on in here, nor do I care at the moment. I'm going to change this though to class name. Just do a little bit of annoyance cleanup there. Oh boy, now I got to fix all the spacing. Awesome, power of pausing videos. So now that we have the window, we need events. So if I go to click on the X on this window, it needs to close, and then that needs to communicate back to Go. So our main problem here is that we're calling the window and the window is taking control. We don't want the window to take control. We are in control of the main. Essentially, we want to do something like Go, and it goes and creates the window. So let's try and get that to work here. So here we're going to call the C window main, and I can just Go that function. And now it should not really do much of anything because the program, yep, there it goes. It ran and then quit. So now I should be able to do a infinite for loop here and have this running, and then when I close it, this is still running because it's in this for loop. Awesome. Now that leaves us with communicating. When I close the X, I ultimately want to quit out of the engine. For now, I'm just going to move this for loop into a more acceptable place here for testing out that quit state. So for that quit state, we are going to get an event coming out of the get messages here. So we're going to get messages from Windows, and we're going to get a bunch of events out of that. So let me find what that event is. Okay, so that event is WM quit. Essentially, if we get WM quit, we are going to write out we're going to dispatch our message to quit out of. Okay, roll back. So when we click the close button, we need it to quit and it needs to break out of that outside for loop. And the way to do that is they have C and Go have to communicate. I don't really want C to call Go because I know that's a little bit slow, and Go calling C isn't bad, so I'm not too worried about that. But it's the other way around, and so I want to create a way of communicating with the C code without it knowing that Go exists, and we'll do that with a pointer. I had this crazy idea, so we're going to try it out and see how it goes. So essentially, what we're going to do is when we construct this main, we're going to pass in a void pointer. We'll call it something like EVT shared mem, and we'll tell it the size of that memory that we passed in. And we're going to use a byte array on the Go side, and we'll communicate just in this binary stream of sorts. So to keep it simple, I'm going to create a couple of defines for the states of read and write access. And basically, Go never needs to write to this array. Go is just reading the event stream from C, and C is just writing to the event stream. It's not really reading anything other than possibly its state saying that it's ready to write some more. So what I'm going to do is I'm going to create a shared mem available, set that to 0, not unavailable. It's going to be writing written. I guess I could use something like reading, but I don't know. That's fine. Written. We need a fatal and we need a quit, just to be explicit with the quit. FE and 0xff. I just see this being written inside of a single byte. So the first byte of the array is going to be this state of the memory. So we're going to start off with C is going to be writing to this shared memory. And so we'll come down here. So anytime that we get a message, we're going to start writing to that that memory. Just for simplicity, I'm going to add in a char star ESM is equal to EVT shared memory. And then we can set here, when we start off, we can say ESM 0 is equal to writing. So that will give us our ability to write, or say that we're writing, so Go would know when we're done writing. And then when we've completed writing it, before we even dispatch it, we can do it a little early. We can write written so that we say we are done writing whatever it is that we have just written. Okay, now we can basically test this out to say when we're out of the event loop here, we can say quit. And we can also put in a fatal here for if the window failed to construct. So now we should be able to set up that byte array and write to it. Now, I could just say something like var event memory and then set some size here, and then it's just a byte array and pass it in. So we'll start with this, but I do want to make a better setup for this so that we have some helper functions. But we'll start with this just to make sure it's working. For not the shared, or if the shared memory 0 is not equal to quit. I don't know what all this stuff is. I just wanted that shared memory quit. So now if we run this, let's see what happens. We're going to have event shared memory 0 is equal to fatal exit status code, probably because this is a void pointer. So let's move this. Let's just put this at the very top, ESM. I guess I could pass it as a char star, but it's a lot easier just to use a void pointer there. And then I also need to pass this as a void pointer. I don't know what I'm talking about. Unsafe dot pointer. And we will use the address of the first byte. Okay. This, I forgot to change this to ESM. ESM. Okay. Return 0. We don't return 0 because this is a void return, so we just say return here. I think that's all it was complaining about. Oh no. Return 0, 76. Yep, this doesn't return. We just exit out of it. We just fall out. Undefined, unsafe. That's because my auto-completion stuff is not working here for some reason. Import unsafe. When I save, Go should be adding those. I think that's what that error was. I might have to relaunch here. So here we have our window. The blue line down here is saying that we're debugging. I'm going to close, and it's going to stop debugging because we fell out of the for loop. So now we're communicating over that event, and I want to clean up that this because I don't want to use just a raw byte array. I'm going to pause the video real quick and see if I can fix my autosave stuff. Okay, for those who want to know, I think it's because I have a capital K for some reason for Kaiju, and it's supposed to be a lowercase k based on the repository here. So that's likely what's tripping it up here. Okay, it's just Visual Studio tripping out. I had to open a different window to a different folder and then open this one back up for some reason. Okay, so we're going to continue on so that this is no longer a just raw byte array floating out there. We're going to create a type out of that guy and make it a little nicer to work with on the Go side. So I'm going to say, first of all, I'm going to extract this const up here so that we have it outside. And then I'll do type evt mem, and this will be a byte array there. So then we can change this to be an evt mem. Okay, and now we can make some helper functions. Event mem is ready bool return. I'm gonna want something like, no, we're not gonna, we can use the C stuff if we were to not make it as defines, but we're gonna have our own explicit Go, even though it's duplicating stuff. The values I'd rather have just the Go constants here. Available, so shared mem available equals iota, and then shared mem writing. And I can always come back and make this file kind of generated with that stuff. But we don't need to worry about it right now. Sometimes you don't need to over-engineer the non-important stuff. This is mostly a one and done. And if I wanted to make this whole memory sharing communication between C and Go more abstracted, then I'll worry about it. But this is just explicitly for communicating with an event stream from C here. So there we go. Make it available. We can have another function for if it is quitting. Is quit. We can have another one for if the memory is available. Or sorry, to get the to make it available. So this needs to be a pointer. Make available. And we're going to do this by setting the first byte to the available boolean. And that should make it a little nicer to work with here. We can probably turn this into a event memory. Oh, is fatal. Yeah, we'll have that as pointer. Unsafe pointer. And we will just essentially take this guy and make this E. Okay. So now we can say evt shared mem. As pointer. And here we can say not evt shared mem is quit or fatal. So this should work as intended. Cool. Now the last thing we need to do, oh, this is still going. If it's not this, and it's not fatal, I should do that. The last thing we need to do is make it so that this Windows file doesn't compile under Linux or the others. It's still here. What did I do wrong? Let's double check. Well, first I'll do what I'm thinking about. I'm going to do go build Windows at the top so it only builds for Windows. Okay, now let's figure out what the heck is going on here. Oh boy, I just realized that I'm not using a pointer here, so it's using the address. That's why they say typically when you use one pointer, make them all pointers, but I don't know. I'm not super into that. Teach their own, though. Follow the rules. So this should make it more. Yeah, now it's working. Cool. So that is setting up the window, getting it to render, and next we can probably sort out getting the events. So let's get the events going without getting too detailed in them, just kind of stubbing it in, preparing it for mouse and keyboard input, that sort of thing. And then I think that'll pretty much do it for this pull request, just kind of getting a Windows window working and functional to be cleaned up at a later time. So we'll start with um, making it so that we can get the events. I think we stubbed it in here. Yeah, so we have the events going to be down here inside of the else. Now, what I'm going to do is I'm going to set up a writing, a, uh, a void pointer for writing data to the to the ESM. What was it called? The event shared memory. And we're not going to do +1. I'm going to consider the first 4 bytes to be just arbitrary data related to this communication back and forth instead of just the first byte. And that also will make it more nicely aligned with how we read and write memory. So technically it'd be like +4. Probably make that a define up here. Define shared mem data start 4. That's where we're going to start writing to it. And now the message that we get back has the event. So you would do something like, actually, yeah, something exactly like that. But we're going to do message there. Message.message actually. And then we will offset the ESM data by the size of the message. And then you could do switch. This is guessing pretty decently here. And this is where you'd put in your stuff like case, WM, L, button down, button up, and let's say case, WM, mouse, move, for example. So you'd be able to get those events coming from C. And we might as well stub these guys in while we're here. And we're not going to do all the events. We're just going to stub in the data for these guys. So I'm going to create a struct inside of C here called input event, and this will just have data for both mouse input, keyboard input, touch input. All the inputs are going to be in one. So we need an X and Y. I'm going to make a union for X, mouse X, and then I'm going to do key here, for example, so the keyboard key is put into there, and then we can do mouse Y, and also when there's 2 extra buttons sensed by the mouse. We have left click, middle click, right click, and then we have X click, which is going to be X1 and X2, which is mouse button 4 and 5. So I'm just going to stub something in here for that, but not actually do much of anything with it. So now that we have a struct here, I'm going to create it outside of the switch. Input event IE, and we can get the X. Yeah, that's exactly what I was going to do. Mouse Y is going to go there, and we'll leave it there. We'll deal with the X button 1 and 2. I'll comment it in IE dot mouse X button is equal to, the W param does have it, but that's not how you assign it. You'd have to do something like message param and 0x0020 is going to be the X button 1. I'm just looking at the documentation here. X button 2 is going to be 40. So I'm just going to comment this in X button 1, X button 2. Okay. And lastly, since we've offset where we're going to write the data, wait a second, what is this doing? Oh yeah, this is writing the message. This needs to be message.message. So we're sending the event back to Go of which event we're getting from inside of C, and if it so happens to be a mouse event, we're just going to go ahead and write in that mouse event data. And I'm going to move all three of these guys into the else case, because if it's a quit, we're breaking. I can just, I don't need to. Do I need to dispatch quits? I don't know. I'll put it. Yeah, I'll just leave it the way it was. It was working fine. Also, I need this written for quit. Do I? No, it's right here. Oh, we probably should. Oh, we don't need written because quit takes over. Oh my goodness. Okay. Anyways, yeah, we move this up here since that's the only time it's happening. Okay, and so that should give us events out of this event mem. And so we probably can add in a helper function for getting what the event type was. Event mem event type uint32. It's a uint inside of this C documentation for message. And a uint is specifically uint32. If we used uint instead of go, that's 8 bytes. So we need to define it as a uint32. And we're going to do some nasty magic here. We're going to say return pointer of pointer uint32 e. Oh, this is going to be unsafe size of uint32 0. Okay. So essentially we're casting 0 as uint32. We're getting the size of that, and we are going to cast that to an int. I think we need to do that. Maybe we don't need to do that. Let me see. I'll try this. See if it's happy. It's upset about... Oh, these are inside of a separate Windows library. I think it's Windows X, something like that. Hold on. I'm checking. Yeah, Windows X.h. Yeah, okay, cool. So we don't need to cast that as an int. Oh, and this window would not be complete if we didn't pass in the name of the window. And also we need to check if we have an event. Just in case some weird stuff has happened. Has event bool. And this is just going to return event type is not equal to 0. Okay. And we'll just put this up here. There we go. So yeah, we're going to pass in the name of the window. So we'll say window name string. We'll pass that in, which means we need to pass it in over here. Window name string, and then we'll go back to the main, and we'll say Kaiju Engine. So here, when we have the window name, we need to convert this window name into a wide char for Windows, and Go has a built-in UTF-16, which is what a wide char is, and it has a encode function which takes in a rune array and returns uint16. So this would take in, for example, rune window name, and this will be our window title, which we can pass into here. And of course we have to cast this to what it wants to be instead of C. So this would be a pointer to a C W char T. And then we want to get to the pointer to this guy. So unsafe.pointer, and we'll get the address of the first rune there. Cool. Close that off. So now we need to add this lastly to this function here. So const w char t window title, and we're going to replace learn to program windows, and we are going to also replace this with Kaiju window class, because why not? Fix some spacing. Cool. So now if I run this, let's see if we get any build errors. Cool. It says Kaiju Engine, which is coming from our main. Awesome. That's going to be it for getting a window showing up for this pull request. The next pull request, I'm probably going to deal with some of these events coming in, or actually I might start setting up some of the other parts of the engine. I like to do the mathematics libraries or the linear algebra stuff first and kind of get that out of the way. And there's a slew of other things to do. So yeah, it may be out of order from window, but we got a window showing, which is pretty exciting. That's one of the things I wanted to do. Cool. I'll see you.